Welcome back to section 4.3. We're going to look at writing formulas when you're given the name of an ionic compound. So you've already done some of this with your representative metals and nonmetals, your group 1, 2, and 3 metals. Okay, but we're going to look at ones that give students a little bit harder time just because they're your non-representative, they're your transition metals. But I'm also going to show you a little trick that you can use if you would like. Okay, so when you're writing a formula, so this time we're going to be given the name, and so we need to identify what the cation and the anion are, and then we need to balance the charges in order for us to determine how to write the formula. And then you write the cation first, which is your metal, and the anion second. Okay, so if we have chromium 3 bromide, okay, so that 3 tells us the ionic charge of chromium. Okay, it is a transition metal. It has varying ionic charge, and so we know that chromium is a 3+ charge, and we know that bromide is the name we have here, the -1 charge. Okay. And so in order to write the formula, basically we want to write out. So we have chromium X, Br, X. We want to fill in with how many chromium atoms do we need and how many bromine atoms do we need in order for these to combine where their charge equals 0 and where they have a stable octet. Okay, and so how you can look at this is if you have a 3+ charge, then we're going to need 3 -1 charges in order to cancel out for every 1 3+. So we need 1 chromium atom for every 3. You don't have to write that 1 there. I just did that just for practice purposes. Okay, and so we get this here. So our formula would be CrBr3. So you have to just balance the charges in order for you to come up with your subscripts. Okay, and remember the subscripts are equal to the number of atoms. Okay, I'm going to show you, we're going to walk through some writing the formulas for the compounds, and I'm also going to show you a little trick if you want to use it. You can also use it when you're writing formulas for your representative metals as well, so what we did back in section 4.2. Okay, it's not as good of a tool when you're naming, but it is useful when you're writing formulas. Okay, so the first thing we're going to do is recognize that nickel, we find this on the periodic table, is that it's a transition metal. It has varying charge. We know that because of our Roman numeral. Okay, but here we're given the ionic charge. And then we know that sulfur is in group 6, and so it's going to have a 2- charge. Okay, when this happens, the easiest way is just to look at this and you see that you have a +2 and a -2, which already equals 0, and so our formula is just going to look like so. You just need 1 atom of each metal and non-metal in order for you to have a complete octet and a charge of 0. Okay, if we look at B, we want to find zinc. Be sure you write out the correct symbol. Okay, and as the more practice you do, the more easier and familiar these will become. Okay, and we know that we have zinc and we have chloride. You may not recognize this yet, as you may have just not noticed that zinc is an exception to our variable charge for a transition metal. It always forms a 2+ charge, so you can find this on page 135 if you want to reference that. Okay, and so we can come up with our formula one of 2 ways. All right, we can go ahead and write out that we have 2 zinc 2 plus, so we're going to need 2 -1 charges in order for us to balance this 2 plus charge. So we have a -2 and a +2, so we're going to need 2 chlorines. Okay, you can also do what I call swapping the state or swapping the charge, but you're not actually swapping charge because you can't have a negative or a negative atom. Okay, but if you look here, and some of you may think this is easier, some may think that this is harder. Okay, but basically, in order for the charge to balance for the ionic compound, the numbers can just be swapped. So this 2 goes here for this subscript and this 1 here. Okay, so it's an understood 1 and then the 2 moves there. Okay, you can't move negative, you don't really move the charge, you just move the numbers. So we get zinc chloride in ZnCl2. Okay, we're going to do the same for iron. We find iron on the periodic table, Fe. We're given the oxidation state of +3. We know that oxygen has a 2- or -2 oxidation state, or ionic charge. Sorry, I use those terms interchangeably. Okay, and so we can look at this way. So we can say that if we are going to need two of these, okay, and some of you may see this because we need a total of -6, and we have a total of +6, and so we need 2 iron atoms for every 3 oxygen. Okay, you can look at it that way, or you can do the swapping of the states. Okay, and so the 2 comes here, and the 3 here. So these are subscripts indicating how many atoms we need of each, and we get the same thing. So either way, you want to look at it just by balancing the charge, or you can simply swap. Okay, you can also do this for your representative group 1, 2, and 3. So say we were given aluminum sulfide. Okay, and we're given the name and we want to write the formula. Okay, we've already gone through this in previous videos, but I'm going to show you how you can do this by swapping the state. Okay, so if you have aluminum, the 3+ charge because it's in group 3, and sulfur, 2- charge. Okay, and we can swap. Move the 2 here and the 3 here to get our formula. Okay, you don't want to do this when you're naming. You want to go through and find the oxidation state if you have to for the transition metals. Okay, but for when you are coming up with formulas, writing the formulas, you can do this and it will work. I hope this helps. Thank you.